In this video, I'm going to go through a second example of variance the long way. If you remember in the first video, our numbers looked pretty similar to this. We had 7, 6, 3, 4, and 5. And when we did it that way, we got a sum of squares of 10, we got a variance of 2.5, and a standard deviation of 1.58. So let's see how things change when we add in an outlier. So our numbers here are 7, 6, 3, 4, and 50 is absolutely an outlier. So let's go through this whole problem. So first thing we're going to do is get the sum n and the mean of this column. So when you add all these numbers together, the sum is 70. N is the number of observations, so we have 5 observations here. And the mean is 70 divided by 5, which is 14. And remember, what we're going to do now is we're going to take this mean that we calculated and we're going to use it to populate this second column. So next to each one of these y's or these scores, we are just going to write in the mean. So we're just going to take this number 14 and rewrite it 5 times next to each one of those numbers. So in this third column, y minus y bar, we're going to take each one of these scores and subtract the y bar. All right, so for each row, we are going to take the score, which is in this case 7, subtract the y bar, so 7 minus 14, and that's negative 7. So 6 minus 14 is negative 8. 3 minus 14 is negative 11. 4 minus 14 is negative 10. And 50 minus 14 is positive 36. And then before we move on, we are going to add together the numbers in this column, because the sum of the deviations should always be 0. And this is a good check for you to do before you move on to make sure your numbers make sense. And I've already done this, so I know that this does in fact add up to 0. So that checks out. And then the last thing we have to do in this table is we have to take each one of these deviations and square them. So each one of those answers that we came up with in the third column, we're going to square. So negative 7 squared is positive 49. Remember, you're only going to have positive numbers in this last column. Any number squared is positive. So you're going to have negatives over here, but don't transfer the negatives over to that last column. All right, negative 8 squared is positive 64. Negative 11 squared is positive 121. Negative 10 squared is positive 100. And 36 squared, I can't do in my head, but I already calculated this. It's 1,296. All right, so again, just make sure you didn't inadvertently transfer a negative number into that column. And then what you are going to do is you are going to get the sum of this column. So when you add up those 5 numbers, the sum is 1,630. And this has a special name. It's called your sum of squares. All right? So once you have the sum of squares, you are ready to calculate variance. So remember from the last video, variance is defined as the sum of squares divided by the degrees of freedom. For now, our degrees of freedom are always going to be n minus 1. That's going to change when we get into our first inferential analysis, but for now, degrees of freedom is n minus 1. So all we're going to do is plug in the numbers that we calculated into this formula. So our sum of squares is 1630. Our n is 5. So 1630 divided by 5 minus 1 equals 407.5. And make sure when you're doing homework assignments that you follow like I do and box in your answers. It's not that big of a deal in the beginning because we don't have a lot to calculate, but once we get into our first inferential analysis, there are many, many, many calculations. So I want to make sure that I can find your answer. So make sure that you box or circle or highlight. All right, so our variance is 407.5. Once we have that, we're ready to plug it into our standard deviation. Standard deviation is the square root of the variance. So we're going to take the square root of 407.5, and that equals 20.19. All right, so just to compare this to what we did in the last problem. So in this problem here, with these 5 numbers, we've got a sum of squares of 1630, we've got a variance of 407.5, and we've got a standard deviation of 20.19. Now remember, when we did the last problem where we had 7, 6, 3, 4, and 50, or I'm sorry, 7, 6, 3, 4, and 5, our sum of squares was 10. So the sum of squares went up really dramatically. Our variance, if you remember, was 2.5, and our standard deviation was 1.58. So look at how those numbers changed so dramatically when we added in a single outlier. So all the other numbers stayed exactly the same, but having one outlier, one number that was outside of the range, caused in this problem a 20-fold increase in the size of the variance and a 10-fold, 15-fold increase in the size of the standard deviation. So variance and standard deviation really give you an idea, a mathematical idea of how variable the scores are in your sample.